Einstein once said, the important thing is to not stop questioning.
Curiosity has its own reason for existence. One cannot help but be in awe when he contemplates the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries merely to comprehend a little of this mystery each day. I'm going to talk about a mystery which I feel is one of the most spellbinding celestial objects in the universe: black holes. Black holes are extremely dense objects that pack a lot of mass in a small volume. A black hole absorbs all matter, including light that ventures too close to it. Past the point of no return, scientists call the event horizon. So, for something to be able to go past the event horizon and come back out again, they would have to be going faster than the speed of light, which is, well, impossible. Theoretically, the escape velocity would have to be 300,000 kilometers per second. Not even light can escape a black hole's tremendous strength. We simply cannot see it. Now, we know that black holes are incredibly dense at the singularity or the core, but we don't exactly know the state of the matter in the singularity. But one way to imagine a black hole's density is, for example, crushing the moon into the width of 2 human hairs. So, how do black holes come to exist? Well, some start off as massive stars, at least 3 solar masses large. In other words, our sun does not even have enough mass to be a black hole itself. While the star is alive, energy generated in the core pushes against gravity, creating a balance between the two. When the star dies, radiation stops being emitted and the balance is broken. Because there is no opposing force, the star's gravity pulls its matter towards the core. Within milliseconds, there's a supernova explosion, and most of the star's mass is ejected, and thus we are left with a black hole. Now, since light cannot escape a black hole, and we can't see them, how do we know they exist? The simple answer is behavior. A black hole has an effect on the celestial objects near it. Those orbiting around it do not get sucked in, just like the Earth orbits the Sun. However, if these planets or stars get too close to the event horizon, for example, if their orbits degrade, they would immediately be consumed. So, should we be afraid of black holes? Well, the nearest black hole, the V616 Monocerotis, is over 3,000 light years away. In other words, even light traveling to us would take 3,000 years to reach us. And even then, it's exceedingly unlikely for it to travel directly towards us. So, I wouldn't be too worried. However, finding yourself being sucked into a black hole with a mass 20 times that of our sun's with no way of escaping might seem a little worrying. I bet you're wondering what would actually happen if you were to fall into a black hole. Well, it actually depends on the size of the black hole. If it was small enough, the force of gravity would be much stronger at your feet than at your head. You would go through a process called spaghettification. You're stretched out like spaghetti with your feet being sucked into the singularity at a much faster pace than your head. But a bigger black hole would involve different circumstances. You would actually continue unharmed through the black hole until you reach the singularity, which is where you meet your fate. Not to an observer. To an observer, you'd actually be annihilated by a firewall at the event horizon. That is where an observer would watch you meet your fate. And the weirdest part is, the laws of physics agree with both situations occurring simultaneously. Not just agree, the laws of physics demand that you die at the firewall and that you continue floating alive and unharmed. So, are you dead or alive? Well, no one knows. Anyways, in some aspects, black holes aren't that different compared to Earth or other planets for that matter, right? I mean, they have size, they have mass, they have a gravitational pull, and just like us, they won't live forever. A black hole could eventually disappear. For supermassive black holes, this could take 10 to the power of 100 years. That's this many zeros. This could happen due to Hawking radiation, which causes black holes to slowly radiate. To conclude, let's talk about time dilation. As a consequence of Einstein's general theory of relativity, imagine a space station orbits a black hole and a spacecraft departs it and moves to a tighter orbit around the black hole. For someone on the space station, it would appear like the spacecraft is going in slow motion, while for someone on this craft, the station appears to be moving in fast forward. I hope one day we will find out the mysteries of this beautiful and uniquely fascinating celestial being. Until then, I hope I've not only informed you, but made you as curious and awestruck as I am about black holes.